I'll introduce the next talk and speakers. Please give a huge round of applause for Sachidanand and Gaurav from my team. They will be talking about unified data platform that envision to make with ClickHouse as the backbone. So um, the team will present more on the insights in the time series use case. We did quite an exhaustive benchmark running for over a quarter, and we will, in the interest of time, just stick to time series. Maybe in a future meetup, if you guys are interested, we can present the OLAP and observability insights. But for now, we will put the requirements, we will put the constraints, and we will tell you the insights that we learned by running time series use case on top of ClickHouse. Can we have Sachidanand and Gaurav Nigam? So Gaurav is a senior member of technical staff at Nutanix and a distributed system enthusiast. Gaurav is the most active ClickHouse user in our team right now and specializes in running time series use cases. Very efficiency at scale on top of ClickHouse. Um, his co-speaker will be Sachidanand, who is another senior engineer and somebody who, as a developer, specializes in database internals. Sachidanand is working on defining this central data platform to work across products, across operating environments, and truly is a great OLAP databases expert for us. So give it up for Gaurav and Sachin. I'll hand it over to them.
First of all, thank you everyone for joining, and thanks Johnny for giving introduction. Oh, you're here. So yeah, that covers some of the things which we want to also highlight. So I, along with Sachidanand, will talk about how we unify data platform, through using ClickHouse. So before we'll quickly introduce ourselves. So you already talked about little bit. So I'm SMTS at Nutanix, regular software developer, love coding, and currently part of data platform team here. And yeah, mainly focusing on backend system, distributed time series database. So yeah, with ClickHouse, I've been exploring the more than 6 months now. So yeah, that's pretty much. I'll let Sachidanand also introduce himself. Yeah.
Hello, everyone. So I am Sachidanand. I am from platform team at Nutanix. So currently, I am working on mainly OLAP databases. I love open source and a regular platform engineer, day in and day out.
Okay, so before we start, quick disclaimer. Today's talk would be based on our own opinion. We are not representing Nutanix here. So that's quick disclaimer. So before we start, let's get some show of hands. So how many of you heard about on-premise, private cloud? I think a lot of. Public cloud, I think everyone knows, right? So private cloud on-prem, we'll talk about briefly. How many of you know about Nutanix, what it does? Some of you have, okay. Nutanix people definitely know, right? So you don't, great. So yeah, and how many of you are using ClickHouse currently? Okay, and others are all new to get some to know about ClickHouse, right? So we'll give some, we'll share our learning what we did, and that maybe that you might get something from us. So we'll try our best. Any other analytical database you have used other than? Okay, Pinot. You might be using Druid, right? A lot of, so okay, we'll talk about this. So our talk is around basically how we unified our data platform through ClickHouse, where we have multiple use cases, and we tried to fit in to ClickHouse. We considering the ClickHouse first approach, basically. So any use case comes to us, we'll try to fit with ClickHouse. That's the plan, and then we'll talk about it. So our talk would cover some context about our problem statement, which we are presenting. What is the need of unified data platform? Workload and use cases that we have currently, and some of the observation which based on our performance testing, which we have been doing from last 6 months, and the challenges we have faced, and the learning as well. So, and last we'll have a Q&A. Okay, so about Nutanix. So Nutanix is basically known for on-premise business. What I mean here, on-premise is like, so our customers are different companies. It could be in healthcare domain, like Sakra, in IT, Walmart, automobile, Hyundai, right? And many more. IKEA is one of them. So we have solution to manage the infrastructure. What do we sell here to customer? Like we can manage. So company basically focus on their own business. They don't want to focus on managing their infra, right? Nobody want to like, they definitely focus on your business. So that's where Nutanix comes into picture and gives the solution where they can focus on their business, and all the infra, storage, network, everything, all the issues that you see behind that to manage the infra, that Nutanix take care of it. So that's the solution we do. This is one of them. I'm not talking about all the product which Nutanix has. So this is one of them. So it also helps customer to build their own private cloud, right? So, so some of the context. So let's focus. Like earlier, we were talking about our product is kind of shipped to different companies, right? And then if we focus on one company, what we do, we basically we have multiple products. The solution which we provide includes many products, and these products has different use cases. And throughout the last 14 years of journey of this Nutanix, we have built our own product, and as well as we have acquired some of the product. So the product which we have built has its own workload. Like we have time series use case, OLAP, logging, caching, transaction graph, all this set of use cases and workload we have. And some of the product which we acquired has also its own workload that is running in cloud, right? So what we want to do, we want to kind of unify our data platform so that same all the product umbrella of this product can run both on-prem, which is in customer environment, and on cloud as well. So our product is also shipped to cloud. So okay, so I'll hand over to Sachidanand to talk more about unified data platform, whatever the need, what all challenges we had. So over to you, Sachin. You can have it.
Yeah, like Gaurav rightly mentioned, when we are having both our workloads in on-prem and cloud, currently we are dealing with multiple databases. So like in the other side, we saw for time series, we are using Victormetrics, in-house DB. For analytics, currently it is on Druid. For logging and tracing, currently we are doing Elasticsearch. So when we have so many databases in the on-prem environment where it is very restrictive, once we ship our product to customer, we cannot control that. So it will be very bad customer experience. So we need to do any day one activities like upgrade and maintenance. So there customer has the control when he wants to do it. It should be one click so that customer has a very great experience. So in that case, maintaining all these databases, mainly we will concentrate on time series, OLAP, and logging tracing. So for other cases like caching, graph, and transactions, those we are not, like ClickHouse is not meant for those kind of use cases currently. So as you can see, when we have multiple database, we have redundant data. That means one data can sit in multiple database for analytics. So the product one is entirely in cloud, and product 2 and 3 are entirely on on-prem. So if they need the same data, then we have to put it in two places. And cost intensive in the sense, let's say maybe resource-wise, it might be comparable, but definitely ClickHouse will consume less resource. But in terms of support, if you want to take, you need to take 3 supports basically for all the database cases. So what we are doing is we are putting ClickHouse first approach here, which we are currently seeing it will be cost efficient, resource efficient, so that the customer will need to spend less resource for the management plane of the Nutanix products. Yeah, so just to put some numbers around, like you can see, these are numbers from both on-prem and cloud. So for analytics, if we see, it is mainly a Druid cluster that handles close to 20 TB of data. We have per day 500,000 tasks. We have 8 million queries per day there. And for time series, if you see, the first 2 rows represents for a single customer. We have 10 to 15 TB of data, and we have thousands of them. So for in cloud, whatever cluster we are running currently for collecting all our microservice metrics and all, that goes to close to 150 million data points for 5 minutes. And for logging and tracing, I think tracing is not enabled in all clusters, but logging data, as you can see, it is close to 60 TB. So just to put some numbers. So currently, as I said, we are on Druid. So when you go on a highway, right, you are entirely free on the speed limit. So you exactly like that, like in cloud, you feel that resources are unlimited, which is not true for all cases, but we think like that. So in Druid now, we are happily running for 4 years in production. So we have, so when we try to put it into on-prem, there are basically 9 components. So Zookeeper, metadata storage, deep storage, those are all external components. So those come from external parties. But Druid on its own has 6 components. Middle manager and overload are for managing ingestion. Coordinator and historical are for managing queries. So coordinator will just distribute the data which is ingested by middle managers in the historical so that we can query. And we have 9 components. We are in Kubernetes. So each component has its own type. So historicals are stateful set. So for that also we need instance store. So based on that, we will have different upgrade and maintenance strategies for each component. In Druid, you have to follow a order so that your upgrade is right. If we try to put all these in on-prem and give less resource also, it will eat up many resources of the customer. So also Druid comes with its own pros. That is, it has 100% read and write segregation. It has, if you want to scale your ingestion, you can do that. If you want to scale your queries, you can do that. But ClickHouse doesn't give that out of the box. You need to apply some hacks like user management, quotas. We have come up with one topology where we can segregate the read and writes. But in that case, also the background merges will eat up 15 to 20% of your resources. Like what we have seen in our performance environment that I'm telling. And one more thing is data rebalance. So whenever you add a new historical in Druid, the coordinator has the responsibility to distribute the data between them, evenly distribute. You can put some cost strategy and it will evenly distribute. But in ClickHouse, you will not get that out of the box. You have to adjust weights, or you need to rebalance all your data using ClickHouse copier, remote functions. That might have some downtime as well. So in that case, as you can see, but we found that ClickHouse is better compressions. Whenever you apply some, let's say double delta on timestamp, then it is like for billion of rows, it is in MBs. Your data will be in MBs. So I think Gaurav will talk about compression in the upcoming slides. So as we see, so ClickHouse has mainly 2 components. One is ClickHouse server, that we can make topology out of it, like there will be shards, but each of them is a different ClickHouse process itself. So in the shards, you can have 2 replicas, 3 replicas, whatever you want. So replication is done by ClickHouse Keeper. So ClickHouse Keeper is mainly for replication and distributed ETL commands. So in that case, when you have two components, you can easily upgrade it. For day one activities, your life will be easier. So these are all the pros and cons I'm saying. So for our use case, for putting, especially in on-prem, we cannot fit it with Druid. But just to put some numbers, as you can see, this in use case one, we are trying to put 1 month data, 50 million rows, and in Druid, we are taking only the resources of middle managers. So in that, the slowest tasks that the P99 task ingestion latency is almost double of ClickHouse. For the use case two, we have 1.2 billion rows. That comes around 13 months data. And here what we are doing is the ClickHouse numbers are from POP environment. The Druid numbers are from production environment. So we are just taking the task duration and adding all of them. So in Druid, as you can see, we have a scaling worker which will scale the middle managers as the task comes. So it has like almost infinite parallelization. With ClickHouse, we tried with 4 parallel tasks. With 8 parallel tasks, we got even better performance. So we have a thread pool. We are just submitting one task after another once one task finishes. So in that case, we got 4.5 hours in ClickHouse and in 9 hours in Druid. And the merges happen in ClickHouse automatically. So you don't need to worry about that. In Druid, you have to set auto compaction or you need to submit the task. So for that resource, actually it is not accounted in this. So as you can also see, like memory says, CPU says also almost 3x. So that's all like I have come up with for now. For the interest of time, I will not dive deep into analytics. We will go to time series and Gaurav will take it from here.
Thanks, Sachin. So before we start on time series, our time series use case, let's get some show of hands. So how many of you are using time series database? Okay, great. And how many of you are using ClickHouse for time series database? Great. I think quite a few. Okay, that's great. So similar kind of when we started evaluating ClickHouse for time series use case around 6 months back, right? We had a similar impression, like a kind of impression like whether we will be able to fit time series use case in ClickHouse. And we were started exploring, right? It's like we had our own in-house database for time series, and we also explored Victoria metrics earlier. And so time series database specific for meant for time series are quite well, right? Victoria gave kind of great performance there. Uh, so what the analogy which I could see why performing Victoria and ClickHouse, it was like Victoria or any time series database is like rented house, right? You just pay the rent and you get everything, most of thing, right? You don't care about what everything owner will gonna give you, right? It's a fully furnished rented house. But about ClickHouse, ClickHouse is like your own house. You have to basically sit with, when you buy a new house, right? You have to go with your interior design. You have to do everything, yeah? ClickHouse, similar, ClickHouse has like hell lot of settings you can't even just go through in a month, I guess, right? It's all like it's up to you what you want based on use case. You can define all those settings and then get your use case implemented. Same thing we did. So with time series, so we'll talk about what our use case is, what is the requirement exactly, and some of the things which we did. So in terms of requirement, we basically need high ingestion rate. We have around 40 million data points per minute. We do batch ingestion, and our batches are not kind of fixed set. We have many client which is ingesting data, and they for different rate and you know and there are multiple. So batch we cannot fix, right? And we also do historical ingestion sometimes. In terms of query, we have a requirement of 60 QPS query per second. Latency requirement PAT is less than 200 milliseconds since we are user facing. A lot of queries are kind of UI facing, and we have mix of time series and OLAP queries. So that is and then that is the main requirement that we had. And so in this talk, we'll talk about how we model the ClickHouse to fit the time series use case, and how we optimize for query pattern that we have and got the desired latency, and how we achieve the ingestion. Our ingestion is, which I mentioned, 40 million per data point, and we have future use case as well. So and also the storage part. So this is typical kind of ClickHouse component. I think some of them Johnny talked about, and but I just put into picture like so. So basically, this is we get the data from data pipeline, which goes to our raw table, where we keep 1 minute data or 5 minute granular data. And we have a roll-up table. Roll-up is some kind of aggregation. Like you aggregate, if you have raw data of 1 minute granularity, want to roll up at 5 minutes, or maybe hourly, then you have a roll-up table, aggregated table, what you can say. So, and we do it through materialized view. We, as and when we have insert, the materialized view triggers, and then it also aggregate your data and write to roll-up table. And on top of that, we have a distributed table. So role of distributed table here is not to keep the data. It's just to shard your data. So let's say you have millions of record, or maybe let's say for simplicity, let's say you have 3,000 record, right? And you chose your sharding key in such a way you want to distribute equally, 1,000. That's where you have to choose your sharding key wisely. There are few open things on this thing which we are still exploring, but yeah, that is the main role of distributed table. So that's pretty much. And the read client is, or read or write client, both basically kind of done through distributed table. We don't connect our client to the raw and roll-up table directly. So that both query and read get your distribution. So this is one of the example of raw table that we have. So what we are doing, we are creating table. We have some this is a time series use case raw table that we have. The timestamp, ID, types, domain ID. There are a couple of more, and the metric name and metric value. And we use the engine. Sorry. Replicated merge tree. We are replicating the data. We kind of a cluster is like some shard and replica combination. So we use replicated merge tree. We partition our data monthly. So you have every month you have a different data. So that's the one kind of sharding, I would say, in terms of partitioning. And you define your order by, as I think Johnny also mentioned, the order by is here the way you store data, right? It's a kind of binary search tree. So data is stored in sorted way, and then that's where you can have your query based on that. So this order by key, whatever this combination you choose, that is chosen very wisely, right? So there are two things which we can share here. So the way we came up with this order by is based on your query pattern. That is important. If your query pattern does not have these fields, then definitely your query will not work. It won't be performant. And second thing, it should be in a sequence of low to high cardinality. So here, if you see the domain IDs, unique values are around 10, 2 to 5, type is our 10s, metric is 100, 500, IDs are 1,000, and timestamp is timestamp. So that is the way. So you need to follow the low to high cardinality to get the better query performance. And we also define TTL because we want to keep raw data for 3 weeks and then roll up data maybe 1 year. So accordingly, in the roll up table, we define 1 year, but in raw, it's 3 weeks. So TTL triggers every some amount of time, like 6 hours, and then if all the eligible data will get purged. So to another point which we, to refine our query performance, what we did, we tweaked our granular size, index granularity, which you can see. So by default, the size of granule is 8192 in ClickHouse, right? So for time series use case, if you see, if we go with the default times granule index granularity, then the problem what we realize, like in one granule, you have around 28 days of data. What I mean here, maybe I'll show in the next slide. So if you see here, one granule is your smallest unit in ClickHouse. And so if you, and most of our queries are like 1 day queries, some hourly query, 1 day query, right? So what you want in one granule, you want to keep only 1 day data. That's where we came up with this magic number of 300, which keeps only 1 day data into one granule. So when you are querying, you are scanning only 1 day data at a time. So that's where you're not scanning any extra data. If you go with the 8192, definitely even if your query is for 1 day, you will scan 8192 rows. So that is the one thing we optimized our time series use case. And some of the other thing, like we also normalize our timestamp column because our data was coming through. Let's say we have a data granularity of 5 minutes, but the client will keep on ingesting in any time in the interval of 5 minutes. So with this materialized column, we were able to normalize our timestamp column, and we were able to get the better data quality and the aggregation. And on compression side, we also applied compression on each columns. So ClickHouse provides a way to define your compression and coding at each column level. So some of them, which Johnny also talked about, low cardinality, all these things, we also applied Gorilla on metric value and on timestamp double delta. By default, we use LZ4. So compression, I mean, there are two ways you can do LZ4 ZSTD, but LZ4 was quite performant because you don't have decompression cost of that. So I'll hand over to Sachin to talk about the ingestion part. How did we achieve the ingestion performance? Over to you.
Yeah. So, so as we saw, like we need to insert 40 million data points per minute. So in that, we have multiple clients which are sending batches which have random number of rows. So in that, we cannot rely on the client to do the batching. So what we are doing is, we are using async insert, which will do server-side batching. So using async native insert, we got 25% improvement over standard sync. So here, whatever you are seeing, the last 3, 4, and 5th, those three settings, like there are other settings as well. Those three settings decide how much time you want to batch your data, how much data size you want in each batch, and how many queries you want to put in one batch. So you can put 20 queries, you can put 1 million rows, and you can put 200 millisecond, up to 200 millisecond you can batch them. So with that, we got 25% improved. So in version 23.10, we found that it is supported. Earlier to that, we were doing the other way, and that way we were not getting our latency in ingestion. So if you see in native async with 17 million data points, that is 900 MB of data, we got 38 seconds, and with native sync, we got 48 seconds. Yeah, so with that, we are concluding this talk with our challenges and learnings. So do you think like it came in one day to us, like we need to do all this? So we found some challenges as well. So as you can see, there is one challenge that currently also we are facing is, once you add a SAD, you cannot distribute your data evenly. Automatically, that is not supported. You need to do some hacks like I mentioned, user management, quota or copier, remote function. And we were not able to achieve 100% read-write scaling in ClickHouse. And you have like more than thousands of settings in ClickHouse. So you need to know your configs before you apply that. Like each config can give you latencies like 10x for 10x, 20x. And previously, it has a steep learning curve in the sense like when I come first time like replicated mastery distributed table, it is like it will take you some days to learn. But after that, when you cluster your ClickHouse, it is also a like little painful with alternative Kubernetes operator. Like currently we are managing our ClickHouse clusters, and your life will be easier that way. And if you, last thing is, if you have only time series, you can use a dedicated time series database as well. In ClickHouse, you have to do so much customization, you have to, but once it runs, you can accommodate like in future, if you want to accommodate other use cases also, you can use that. If you are using some other things, you can only add time series data. But here you can add analytics, you can add logging, tracing, anything you want, you can fit in to ClickHouse. Yeah, with that we will go to Q&A.
Yeah, so this is how we are building our house. Open for question. Yes, Mike. Thank you.
Hello. Yeah. So you mentioned previously you're using Victoria metrics, right?
Yeah.
You considered. So what are the advantages that you got from using ClickHouse? First question is that, and there is a lot of tooling around Victoria metrics, right? There is a scraper, then there is a alert, VM alert, and all those components, right? So did you build those components as well?
So I got your first
VM,
question. Sorry.
You can. Is it working? The mic. The mic is
Okay.
working. It
It's
is not
working, right?
audible.
Yeah, it's working.
You're able to hear me, right?
Repeat again.
Yeah. So the first question was, you initially were considering Victoria metrics, right?
Yes.
And you moved to ClickHouse. So what were the advantages that you got from moving to ClickHouse?
Okay, so I'll answer that. Maybe second question I'll take. So definitely, so if you have, as we are recommending as well, right? If you have only time series use case, we are recommending to go with that Victoria. Victoria matrix perform well with because it meant for time series use case, right? But with ClickHouse, as we are presenting our talk on unifying data platform, we have multiple use cases. Observability has three part, right? Your metrics, your log and traces, and other OLAP use cases. So if you have such use case, then we definitely prefer ClickHouse because ClickHouse can support your time series use case. Other part, like there are a couple of things which you cannot achieve with Victoria metrics directly, like the roll-up part, right? It's not free. It's with not open source version, right? So you have to build your multiple cluster where one cluster will have only raw data, other will have roll-up data if you want to have the roll-up requirement. So some of things which we found, and there are kind of few point Victoria is winner, for some other point ClickHouse is winner. So
Yeah, like one more point is like in time series queries, you will get better performance maybe there. But in OLAP queries, you will definitely get in ClickHouse, you will get your.
Okay. And did you build like all the other toolings around metrics, like say alerts, right? So Victoria metrics has this VM alert, and then you have VM agent. So all those components you also built to have over ClickHouse?
Uh, so we have our own alert manager, and you're talking about alert, right? So yeah.
Huh.
Yeah. So what we are doing today is that our vision is that a lot of use cases can be done just on ClickHouse. The problem is, if you use a Victoria Matrix today for your time series use case, it works really well. But if you want OLAP, then you have something like Druid that we used to use earlier. Now, we had Elasticsearch for logs and stuff like that, right? Time series is the first use case. It takes some time mapping all the requirements to ClickHouse. To add to what these folks covered, there are n number of configuration in ClickHouse. You will have to put your head to it and think what configurations can be useful. For instance, if you have a bunch of shards in Victoria Matrix, your query will go and gather data from everywhere, try to sort of make sense of it, dedupe it, and give it to you. In ClickHouse, you can just skip some shards because you're not going to be having data there and stuff like that. So little optimizations, there are a lot of them. The other thing about using ClickHouse for us, I think Gaurav covered already. For observability specifically, right now, we've not moved to ClickHouse, but we've started with this use case. In future, we want to put OLAP on ClickHouse, and having looked at a lot of success stories, we really believe that log can also sit on top of ClickHouse. You might want to see a couple of blogs for success stories that stand out for me. I've read them at least 5 times at different points, right? One is by Uber, right? Uber has a logging blog where they've used ClickHouse, and it's very, very good. Zerodha published a blog where they moved from Elasticsearch to ClickHouse. ClickHouse, I think the team covered already that their compression is amazing. On the Zerodha blog, they will show you with numbers that it's 20x less disk space that's required to store the same amount of data, which also means when you fetch some from ClickHouse server to your application, only certain parts of your data will be moved because they are compressed. You are transferring less data, less latency, less transfer cost. So we really believe that all of that logging alerting can sit on ClickHouse. We have not figured that out completely, done benchmarks and all, but that's in the pipeline.
Thanks, you.
Yeah. Hello, this is Ajay. So how do you manage cardinality in ClickHouse? So basically, in my company, I use Victoriometrics and it's doing great actually. So we have a plan to, split some data into ClickHouse. So I'm worried about the cardinality. So
Okay.
Victoriometrics is already managing, somehow it will manage the high cardinalities. So my question is, how does this ClickHouse manage the cardinality problem?
So we have a evaluate time series use case for the cardinality of 40 million. We did not see such issue in terms of. We have a large customer like in terms of since we are infra, we provide infra solution, right? We have VM cluster and all these things. In terms of VM, we have around 200K VMs worth of data, which has cardinality, and we also have a application monitoring use case coming in future, which becomes total around 40 million time series use case. So we did not see as such any issues.
So ClickHouse, so do you want to explain a bit more on exactly what is your issue with cardinality? Can we have the mic? Yeah. So ClickHouse actually has amazing compressions. So when you use those and model your schema right. For instance, I remember when we were modeling our schema, Gaurav came with 4 different ways to model it. We had a huge discussions that ran to 2 or 3 different days of different calls and everything. And compression is something that reduces your storage space so little, moving data around so little. I don't see cardinality being a huge problem. But I would like to know exactly what's the problem with cardinality.
Yeah, it's not about the storage actually. It's the choking the resources like CPU or RAM, basically RAM. So some applications like coming without proper instrumentation with more than 10 plus labels with a lot of, the values change, right? Label, random labels.
Right.
Cause a lot of cardinality. So how does this ClickHouse solve that problem? Not about the storage part.
Correct. So we do have that use case. And we didn't really see anything in our benchmarks to tell us that ClickHouse struggles with it. So in our benchmarks, it worked pretty well. Gaurav gave you the numbers, right?
We did struggle on a part so if you see application monitoring, it has a lot of tag value pair, right? All this which define your cardinality, the unique value of tag value, right? Which you define your cardinality. So
Yes.
that's where we did some kind of we're doing it, but when you roll up the data, right? That's where you face issue. By default with raw data, you will not face, because there are ways to we are exploring different model, like either one thing you can keep all the tag value in an array, right? But array has some issues in terms of your, when you roll up, you have to group by it. When you group by on the array, then definitely that will create an issue. So we
yeah.
So there are challenges. It's not straightforward. It's just that you have to tweak your model in a way that you can fit. But what we realize, we can fit it with ClickHouse.
Right. So
Yeah.
Sure. We can talk after.
Yeah. So
Thanks.
I think primarily you will have to, I don't think there is a single answer that I can give you which will tell you that it will work, right? In our case, like Gaurav explained, we went through a bunch of different ways to model our schema, and given our own use cases, for those we could design the schema right and then get by it. Like for instance, he described that we try to use arrays, right? and then rollups had some problems. So depending on what are the other things you're trying to do, you will have to design your schema around this problem. This is one of the big problems. So, but we can catch up in the networking session again to know the exact problem, and then we can propose something. Other questions?
Thank you for sharing your experience with that. So how do you manage the duplicate data? So the duplicate rows coming, right? How do you manage that?
Duplicate is something we are currently, so there are different ways. One is replacing merge tree, right? That's the one which.
No, the problem is, let's say you are doing replacing merge tree, but then you want to do aggregation on that.
Yeah.
So your aggregation will carry it, right?
That is something we are exploring. There are different ways. There are blocks to get the regarding the duplication. One is we are making sure our ingest does not send duplicates, but there are cases if error happens, and then you might rewrite the same rows. This thing. So to be honest, we are still working on it on duplication part, but there are ways which we currently exploring.
Okay.
If you want to add on duplication.
Yeah, one thing I found is that replacing merge tree, but when you are doing that aggregation and all, sorry.
While doing aggregation, replacing merge tree won't help you.
Yeah. So aggregation, in that case, I think ClickHouse is that block level thing. Like if you send same, like if when ClickHouse is creating the block, it is creating some hash ID and it is storing. If you give the same insert again, within some amount of time, it will reject that.
That is only in the first table, but in the second table it won't, right? Because
Can you use the mic, please? Yeah.
so let's say
But first table is not having duplicate.
So
I
think
that is
you
because
won't
in the
get
same table, if you have different parts coming with the duplicate, the replacing merge tree will do that. But let's say that will be on the merge circle, it does that. But before the merge circle, your aggregation will happen. Your materialized view will get it. So it would have already materialized. Those duplicates won't get removed.
Right. I don't think,
It depends
in my
on case,
opinion,
actually.
you can get a promise that duplicates will be removed in time perfectly with ClickHouse. I mean, generalizing that to OLAP databases, I feel,
Unless
difficult
you
to-
handle it while inserting, you make sure there won't be any duplicate.
Yeah, that is one way. Metallization, you rightly pointed out, will have that problem if you do merge tree to do that, because merge will happen later. As you insert, your data will go to this.
Right.
If you can design your aggregate in a way that does not cause a problem, it's use case dependent. You can't always do that. But I don't think ClickHouse will guarantee you a way to avoid duplicates. Look, absolutely deduplicate your data.
The other way to get it at query time, right? So you can also remove duplicates.
No, but the problem is like when you aggregate, you would have already did all your calculations.
What aggregate function are you talking about here?
Any stats. So let's say you have availability kind of a stats you are giving to a customer saying that how long your network was up or it was down, right? SLA calculation, things like that. So while
If
doing
you are
the
giving it to
aggregation-
your customer to define their aggregate function, it's even harder.
No.
I mean, in our case,
we will do that.
Right.
But we are giving the aggregation has to be perfect. You can't have duplicate in that, because
Correct,
then you
correct.
will give wrong information, right?
I don't have a good answer to be
Like
frank.
in
I don't think any OLAP database will guarantee you that.
So currently we are using MySQL and there won't be any duplicate, right?
Correct,
So
correct.
moving to ClickHouse, we have
That's, I think, more of a thing of the relational data OLTP world where we get those kind of guarantees, but that comes at a cost. Here, like Gaurav said, on ingestion time, try to do some things, rely on.
But I think all the time series will have the same problem of duplicate. So there
Correct.
might be
But
some way
in
maybe I'll
time series, you are not looking for exact answers. So yes, statistical modeling, right?
Yeah.
So we are not so worried about duplicates in this use case.
Yeah, but there will be use cases in time series as well. You can't have duplicates.
For instance,
is the same
You
I
can't-
said,
yeah, you can't
SLA
have
calculation and things.
That's not, I mean, duplicate might happen, right?
Yeah,
There are
duplicate might
many
happen.
cases.
Yeah, in this case, duplicate will come, but it will skew your output.
It will.
It shouldn't happen.
I mean,
Right.
I think for us, the ultimate use case in this case is a bunch of visualization dashboards, right? So their duplicates are not as bad.
Yeah.
But if you have a use case where it is a problem, then yeah.
In fact, even
I don't know
log
what-
use case duplicate is not a problem, but
Exactly.
yeah.
So we don't have that use case yet. But yeah, I don't think OLAP database itself will be sufficient to give you that alone. You'll have to design around it in the
Yeah.
application somewhere, either producing data time, consuming data time somewhere.
Thank you.
But thanks for the question. Yeah, we have a QA team also sitting here. They noted down for your this duplication.
Yeah. But that's a good motivation. We will also look at our design to see what problems it can have.
Hey, my name is Vivek. I have a question. If your database is customer facing, that means customers can write their own queries and get the
Not audible.
better?
Yeah, now better.
Yeah, if your database is customer facing, that means customers can write their own queries and get the insights out of it. What tips and tricks do you normally use to make sure that they don't really give a bad query in terms of inefficient queries?
Do we have a use case? We are. I don't personally don't have that use case where user can write a query.
We have some use cases on Druid. You want to
Yes.
talk about it, or I can?
You can tell.
Sure. We have that trouble, right? So what is your exact concern? Is your exact concern that one query will bring my database down because it's a badly written query generated from the UI or something? Or is your query that I'll get bad answers for certain queries? What is your primary concern?
So only thing is the efficiency of it. For example, if somebody writes just a select star of something of a very big table, right? Now, how do you make sure that the database is actually protected from all other things, right? Because it can, we have a SaaS solution, which means that one customer trying to write a bad query will.
ClickHouse, for instance, you can define on the query level quotas, right? The user level, you can define quotas. So one thing is that you can define quotas so a certain query does not end up using or a certain user doesn't end up using more than a given amount of resource. So that will protect your other users or other queries from behaving badly because of this. We have had use cases where like people select things on the UI and that generates an SQL query that executes on the database kind of things. It's a difficult use case. I mean, a lot of times we have had troubles where we upgrade some random queries generated there, doesn't work properly and stuff like that. Right? So it's hard. And with automation, hopefully you can run all those automation of all the things that you can think of and then make sure that your application can handle that. That's how I would probably try to do it, right?
And you, one way to don't expose your ClickHouse read part directly to customer, right? You have your one layer where you can put those validation,
Right.
So that the data model you have made, right? It has to be the order by thing you choose, right? So filter has to be there. So those kind of thing validation you can
Right.
put,
Right.
and that's where you can
Right.
kind of
So-
get away from this issue.
It's hard. I mean, but you will have to build the layer in between or something, depending on your exact use case. Again, what are the things that are fine to disallow? You can think hard on that and then put that middleware in between to make sure that those things are addressed. For instance, make sure that absolutely every query, every user is given quotas. That's one example I gave, right? So make automation, like I said, so that all different kinds of queries can be automated and can keep running on your integration pipeline, right? CI/CD pipeline. But yeah, I mean, we struggle with that as well, right? But we have the layer that he talked of, right? So we have a layer where user selects things, it goes to a library that generates SQL for us. And when we generate there, we know exactly what kind of queries we are going to generate. Apart from things that we generate in library, we know that other queries won't come, right? So if you keep it completely open, it's very hard to solve. You'll have to limit it somehow and then put the guardrails and then execute those. If you just expose it, it's very hard to manage. Right.
Do you use any APM on? So just to add a few more things on that. So do you use any APM just to like find out what are the slow queries that we are running and all? Like, do you use any APM just to find out what are the slow queries and why, if I'm running any query, why it is being slow? And let's say it come across, so recently we have came across like a lot of queries taking time. So, and we found out through APM. So are you using any APM through on the ClickHouse?
Um,
No, I did not.
sorry,
Application like Grafana and New Relic, something
can
similar
you
to
be
that.
louder?
I'm telling like Grafana or New Relic.
Right.
Just to
You're
find out
saying your queries are coming via an API and landing on the database?
yeah.
So a Grafana firing queries on ClickHouse, not the user writing it himself. Is it that what you're saying?
Performance
monitoring. APM performance monitoring on what kind of queries are coming, how are they performing?
Okay. We kind of monitoring tool like Grafana. How do you query ClickHouse for those kind of use cases, right? So for us, for the metric use case, we do have our own dashboard where we show all these metrics and all, and we have our own query layer where we convert the user query in form of GraphQL and convert into SQL. And ClickHouse has kind of all kind of the time series kind of query support. It has all of time series function which you can apply on your tables, and then you can get time range data, graphs, and all everything.
Are you talking about performance monitoring for ClickHouse performance exactly to make sure that ClickHouse is working well, and if it is not, or are you saying that I want to use ClickHouse as the database to do my to have that performance benchmark data sit in ClickHouse? So
mainly on the API level. So let's say I'm using my ClickHouse as a database, and then I'm hitting any API and just doing the query from the ClickHouse. And maybe I have written some wrong queries, or maybe some new data. I have inserted some new data where I don't know where to put index on as of now. And so to solve that problem, I'm asking on regarding that. So maybe we can connect after.
I'm not sure if I got your question right, but we can connect.
Yeah, we can connect later.
We do a lot of time series, right? So your performance data, if it is time series, then some of these apply. If it is beyond that, then let's connect offline, right? I'll be around. Yeah. Sure. Maybe last one or two question in the interest of
I
time.
was about to ask a question, but I think I will answer his question. I'm here. I'll stand up.
Okay.
So I think you were asking, how do you figure out if your ClickHouse cluster is working the way you intended it to, right? You want to figure out how your ClickHouse cluster is working, correct? Whether the queries you wrote were taking too long, all that thing, right? What is internally happening? So the best thing is ClickHouse stores all this data internally and exposes it inside its own system tables. So all you have to do is just query those tables and you will get everything. Which query is slow, what are the tables, what are the partitions, how much memory is taking on the disk, everything. I don't think you have to go out. You can look inside. You can use Grafana. There are 3 dashboards which Johnny was talking about. And you can I think I have a screenshot we can talk to back. I hope that answers the question. And we have a question.
Last question. We are way behind time. Yeah.
Okay. By the way, for the query thing which you were saying, you can have a limit on the time it takes, and then you can shut the query off in ClickHouse. So you can use that for query. Okay, that aside, I wanted to ask about the sharding. How do you rebalance it? It has to be manual. That's the first question. And second was the sharding keys. You told that you have your own sharding keys, but I read about that you normally want to do just random so that your data is equally going to different shards. So do you have a case where you have a different key for sharding?
Yeah, with multi-column sharding, we are also facing some issues.
I didn't get that, sorry.
If you use multi-column sharding, right?
If you have a composite sharding key, was that your case?
Yeah, what was the use case for the composite sharding key? Because I have read that it's usually good to have a random key in the sharding key so that all the data goes into different shards.
That's what we are currently we are analyzing what combination will work for us.
Am I audible? Yeah. So that's under discussion really. So what we as platform team is recommending is use random. and the app team is more biased towards using composite key. And we've seen issues in ClickHouse where if you have a lot of fields in clause, then and you have a composite shard key, so ClickHouse optimizes the in clause saying if a particular field will not be present in that shard, so it is going to remove that. When you use optimize unused shards, so that breaks for composite shard key in ClickHouse. So anyway, in ClickHouse, if you have multiple fields in, the query is going to be distributed on most of the shards. Then you're not really using that unused shards optimization. So that's why we say that instead of sharding it on basically multiple columns, a key with multiple columns, use random, because anyway your data is going to be distributed randomly, and our queries have a lot of fields in clause, so the queries also will land up on most of the shards. So we don't really need a sharding key, and random will work. So I hope I answered.
Yeah, that pretty much answers
Yeah.
it.